Hi, everybody, and welcome to lesson 4.2. Today we are beginning on page 45 in your Springboard book, and we are definitely going to be wanting a pencil, a highlighter, and a calculator. You may also want some multiple colored pencils or if you have them available to you. Okay, now notice here we have a bunch of different angles lined up with a protractor. And what a protractor does is it allows us to measure our angles. So what you're going to see here is that for angles that are looking like they are acute, we are going to use the smaller numbers than 90 degrees, aka for angle AOB, this is 50 degrees, right? Like they have here. And BOC, then right here, is going from 50 to 90, aka it measures 40 degrees. And then altogether, angle AOC is going directly from 0 to 90, so it is a right angle and is 90 degrees. Now, what you're possibly noticing here is this lovely pattern, similar to what we talked about in activity or in lesson 4.1, that small guy plus small guy is equaling our big guy. And what that is known as is our angle addition postulate. Again, small guy plus small guy equals big guy. Just like it worked with segments, it's also going to work with angles. Now, a lot of times what you're going to see is they're going to give you an angle like they do here, angle A, B, C, and then they're going to tell you that there is a point on the interior. That means we have a ray coming from our vertex to that point that is dividing this into two angles that make up our big angle. So small angle plus small angle equals that big angle. Okay. Now, looking at this in context, what are you guys supposed to do with it? Well, first things first, let's get rid of this so we have a little bit more room, okay? But you always want to draw pictures and label them. I'm going to make this nice and big. That's how you're going to start. Just like we did with the segment addition postulate, you want to do the same process with the angle addition postulate. So for part A, okay, we're going to start by drawing the angle they are giving us, which is XYZ with P on the interior. So here is our angle XYZ, and here is point P in the interior of that angle, right? So we have ray YP. And they are telling us that XYP is 25 degrees, and then we know that angle PYZ is 50 degrees, and together small guy plus small guy is going to equal our big guy, XYZ. So 25 plus 50 is 75 degrees. Okay. Now, part B, same idea. We want to start by drawing a picture. I'm going to put point B over here. And here's our picture. And this time our angle is called RTD. So here's R, here's T, here's D, and point M is on the interior. I'm going to draw M somewhere inside here. And this time our angles, we have RTM, which is measuring 40 degrees, and we also have given to us RTD is 65. So notice that's the entire big angle. Now this is where drawing the picture comes into play, because they're not always just going to give you the two small angles and assume you're going to add them up. This time we have given to us the small angle, but we don't know the other small angle, but we know together they add up to equal the big angle. So this time we're not going to add. What we're going to do is we're going to subtract 65 minus 40 to realize our missing angle is 25 degrees. Okay. Now, part C is over here. All right, here's part C. And part C then is asking us to draw an angle. So here is EFG, and we want point H on the interior. Now I know you missed it, but here comes algebra again, right? Because they're giving us that EFH is 75. They are giving us that HFG here is 10x. And then last but not least, they are giving us that the whole angle EFG is 20x minus 5. Now, again, we need to set up an equation that's going to actually allow us to solve for that missing piece, right? So small guy of 75 plus small guy of 10x is going to equal our big guy of 20x minus 5. Now we're going to be able to actually solve that because we could subtract 10x from both sides and add 5 to balance this out so that we end up with 80 on the left equals 10x on the right. Divide by 10 and x equals 8. Okay. Now the last piece here wants us to plug it back in. So if we want HFG, we want H to F to G, which is 10 times 8, which is 80 degrees. Okay. Now, anytime they are giving us something, some angles in a picture, like we have in part D, they're first off telling us that we have two lines intersecting. So notice what we are doing here is creating some vertical angles. And they're also telling us one of those vertical angles is 44 degrees. And they're also telling us that this angle here, AFB, is 61 degrees. Okay. Now, couple things we know. First of all, those vertical angles have that congruent measure that we talked about in that last lesson, these vocab words, and that means they have the same measure. So we actually know right away that angle EFD down here is also going to be 44 degrees because of its vertical relationship with BFC. Now these other angles, including AFC, AFC is right here. And to find the measure of AFC, we need to take our two small angles, 61 and 44, and add them together to get our 105 degree angle. AFE, on the other hand, is right here. Here's A to F to E. And notice a couple ways we could look at this, but notice we have our 44 degree angle here, our 61 degree angle here, and then this guy. All three of those together create a straight angle, aka an angle that's 180 degrees. So if we know this whole angle is 180 degrees and one piece of it was 105 degrees, 180 minus the 105 leaves this angle to be 75 degrees. Okay, so using those pieces together will help us solve. Now moving on, just like we had the bisector of a segment in the last lesson, we also have the bisector of an angle, which is always a ray. Because remember, we're going from that vertex to that interior point. And this interior point is special because this ray is going to cut our angle into two congruent pieces. Remember, this is our symbol for congruent, okay? So for instance, if we are given that we have a picture called an angle called MAT. So here is MAT, angle MAT. And notice this key word here, that the ray AH bisects our angle. We are allowed to draw this then so that we know this is equal to this, right? They are congruent. So our tick marks here, we have a couple options. Sometimes you could put like a double tick mark situation. Sometimes what you're going to see is like little lines here to show that each of those have one dash in them, so they are congruent, which means if our entire angle MAT is 70 degrees, that means each of these, if we divide this in half, each of them would have to be 35 degrees, including MAH, this little guy here. Okay. Now, on the flip side, if we look at part B here and we have that same picture, and they told us HFG one of the smaller angles, was 80, what then does MAT have to be? Well, the big angle, if this is being bisected, this would also be 80. So together, they would be 160 degrees. Okay. So drawing that picture will make your life immensely easier, and looking for those key words, including bisects. Okay. Now, moving right along again, they give us another example. And again, always start by drawing your picture and labeling so that we can easily identify what's our small angle, what's our big angle, and it will also help us to solve for missing pieces as well in what we're solving for. So in the picture over here, if we do part A and we draw our picture, notice for part A, they're telling us we have an angle named AFM, AFM, and FL bisects. So we are allowed to draw this so that we know that these have equal measure. Okay. Now, in this first problem, they are giving us that LFM is 11x plus 4, and AFL is 12x minus 2. Well, what do you know about these two angles? Well, because of that keyword bisects, we know that they are equal to each other. So 12x minus 2 is going to equal whatever 11x plus 4 is. And if we subtract 11x from both sides and add 2, we get x to be 6, which means if we plug this back in, LFM is 11 times 6 plus 4, which is 70 degrees, which means this is also 70 degrees, and the entire angle AFM is 140 degrees. Now, sometimes what you're going to see is going to be like the next part we're going to talk about here with this problem. And if we just erase a little bit of this, let me draw this in, notice that in this particular problem, then, next, we're using the same picture and the same given information, but this time they are telling us that AFM, the entire angle, is 6x minus 2, and then they give us that AFL, this little guy here, is going to be 4x minus 10. Now this time we can't set them equal because we have a small angle given and this big angle. They're not equal to each other. What we do know, though, is that 4x minus 10 plus its congruent buddy 4x minus 10 has to equal 6x minus 2 because, again, that ray was bisected. So on this particular problem, then, to set up and solve, we're going to want to treat this like we did on the last problem where we take 4x minus 10, 4x minus 10 plus 4x minus 10 and set that equal to the big angle 6x minus 2. Okay. Now I'm not going to finish solving it just to save time, but I'm going to leave that to you guys, and then make sure you also plug it back in. All right, last but not least, we have to talk a little bit about, our friends complementary and supplementary. So for instance, it says here that the measure of angle A and the measure of angle B add up to equal complementary angles, aka they add up to be 90 degrees. So what we can do here is we can take the measure of angle A and the measure of angle B, 3x plus 7 and 6x plus 11, and substitute that in so that we can solve for this. So anytime you see complementary, again, your key is that they are going to add up to equal 90. And if we combine like terms on the left and then eventually start subtracting from the right on both sides, we end up getting x to equal 8. And we always want to double check, can I stop there? Because notice it doesn't say anything about x, it wants the measure of angle. So we're going to plug back in for the measure of angle A, 3 times 8 plus 7, which is 31 degrees. And we're going to plug into angle B, 6 times 8 plus 11, which is 59 degrees. So that's our final answer on that one. Okay? All right. Next page then wants you to look at this diagram here and think about the relationship between these two. Right? What is that relationship? Well, hopefully you notice they are adjacent and supplementary, aka they are forming a linear pair. So to set this one up, we are going to want to add these two angles together and set them equal to 180 degrees because they are supplementary. Okay, now when we solve here, combining like terms, plus 68, and then we're going to subtract the 68 over and divide. Something that we're going to notice here is that they want us to determine the measure of angle CEB. So when we plug this back in, I'm going to erase this so we see this a little better. Angle CEB is this guy right here. So a couple ways we can do this, but probably the easiest way is to notice that these guys are vertical angles. So if I plug x back in here to 5x plus 68, what I'm going to notice is that this is 108 degrees, which means its vertical angle also has to be 108 degrees. All right. Thanks, everybody, and have a great rest of your day.